In today's tutorial, we'll walk through creating a scene that moves through a warped grid. This is sort of an update to the old twisted grid scene tutorial, but using more modern RayTK features. I created this version of the scene as an exercise in applying different kinds of distortion to repeating patterns and seeing what kind of weird stuff happens in the distance. So the focus here is going to be on building the scene, so we aren't going to get into as much detail about the theory and mechanisms involved. If you're interested in that stuff, check out the videos in the RayTK intro series. We'll be using RayTK version 0.35, so make sure you're using at least that version. Check the video description for a download link. Start by dropping the toolkit talks into your project. I like to do that at the root outside of the main project comp, but you can put it wherever you want. We'll start by setting up the renderer and a basic camera and light. Then we'll create the shape that will serve as the cell that's repeated to form the grid. Then we'll tile the cell to make the grid, and then apply a few types of spatial distortion to it. Then we'll set up the material and a final camera and light source. And finally, we'll add some motion logic to have the camera navigate through the grid. Unlike in most of the previous RayTK tutorials, in this one, we're going to create our scene within a base comp inside the main project comp. We'll do that so that we can add custom parameters that control the scene. The idea is to create a self-contained component that lets you control the scene and use the rendered output without having to dive into the network. While you could do that on the default project comp, I find that it can be a bit confusing when the scene is also a panel component, which that project comp is by default. And it can be annoying if you want to move the scene around without moving the root of your whole project. So create a base comp, and then you're going to name that scene. And I'm just going to use this one that I've already created here. Navigate into the scene comp. We'll start by setting up the renderer. Open the RayTK palette using the Alt-R shortcut, and create a RayMarch Render 3D. Then create an out top connected to the first output of the renderer. So this is going to send that scene's rendered output to an outlet that you can then use from outside of that component. Select the renderer and open RayTK's Editor Tools menu using the shortcut Alt-Shift-R. Then under Add Camera, choose Look at Camera. On the camera, increase the FOV angle to around 60, and we'll keep the default position of 0, 0, and 5. We're going to be replacing this camera later on, so this is just a placeholder for now. Select the renderer again, and open the Editor Tools with Alt-Shift-R, and then under Add Light, we're going to choose Point Light. On the light, let's set the position to 1, 2, and 3. Like with the camera, we're going to adjust the position later on, so this is just temporary. It would be useful for whoever is using the scene to be able to control the render and resolution. So let's expose that parameter on the parent comp. Select the renderer and open RayTK's Editor Tools menu again with Alt-Shift-R. And then under Expose Parameter, I'm going to choose Resolution and make sure you get the first one here and not just one of the parts. This will pop open a dialog with a few options. We're just going to use the defaults. Click Expose. This will create a new custom parameter on the parent comp and bind the corresponding parameter on this component to it. Right-click in an open spot in the network and choose Open Parent Parameters. So this is where you'll be able to edit those parameters from outside the scene. As we go through the scene, I'm going to use this panel off to the side here but it's effectively the same thing as doing that right-click and open parent parameters, just for sake of saving screen space for the tutorial and putting that in a separate panel. But for you, it may be helpful if you have a second monitor to open that parameter pop-up and then place it on a second monitor. You can also right-click in the network and choose Customize Parent Component. This will open Touch Designer's component editor dialog. And you could also try dragging a parameter from here into this list, and it will give you some options to create the binding. But the RayTK expose parameter tool is just a shortcut for doing that. We'll switch between the expose tool and the customize dialog depending on what we need to do for each parameter that we're exposing. Next, we'll set up the shape that we'll be repeating to form our grid. Open the palette with Alt-R and create a box frame SDF. And then connect that to the first input on the renderer. Drop the thickness to around 0.05. This is going to be the frame of the grid. So let's add a scene parameter to control the spacing of the grid. For this one, we're going to create it manually for a reason that will become apparent in a bit. So right-click in an open spot in the network and choose Customize Parent Component. For the name, type in grid size, and you can include a space in it, and we'll automatically clean that up. And change the type here to XYZ, and then click Add Par. This will create a new parameter there with that nice label with spacing, and then the actual name of the parameter is the proper condensed form. Change the default for all three parts to 1. Now for XYZ parameters, or parameters that have multiple parts, it doesn't really make that much difference what the range minimum and maximum are, but it's useful when you're creating a scene like this with some exposed parameters to at least 4 slider parameters to give like a reasonable range with that and a good default. And for these multi-part parameters, we can't really do much with the range because there's no slider, but we can at least pick a reasonable default. So closing the component editor, go to the parent comp and the scene parameters in it. And then you're going to right-click that grid size parameter and choose Copy Parameter. Then go back into the scene and on the box frame SDF, right-click the Scale parameter and choose Paste Reference. For this one, we're using an expression here rather than a binding, since we're going to need to add a little bit of padding later on. So the box scale is actually going to be slightly larger than that grid size parameter on the scene. But for now, we'll leave those expressions as they are, just using the direct values of the grid size. Let's also expose the thickness parameter here. So select the box frame SDF and then open the tools menu with Alt-Shift-R, and then under expose parameter, choose thickness and just click expose. To give it more variety, let's add some shapes on the corners. So create a sphere SDF. Select both the box frame SDF and the sphere, and open the editor tools with Alt-Shift-R. And then under Combine SDFs, choose Simple Union. And then connect that combine to the renderer instead of the box frame. So this gives us a single sphere in the center. Now there are a bunch of ways that we could turn this into individual spheres on each corner of the box. But in this case, I think the best option is to use mirror axes. So open the palette and create a mirror axes operator, and we're going to insert that between the sphere SDF and the combine. Change the axes to XYZ so that we get it reflecting along all of the axes. And then for the offset, for all three parts of it, increase that up to 1. So that spreads out the reflections of that sphere so that we now have effectively one on each corner of the box. We want this offset parameter to always match the spacing and the size of the grid. So let's go to our parent component and the parameters. We're going to right-click grid size, choose copy parameter, go back to the mirror axes, right-click on offset, and choose paste reference. So now if you go to the scene parameters, you can adjust the different parts of the size there, and it's always going to keep those spheres on the corners. But for now, let's keep the grid size at 1 for all of the parts. It'd be useful to have a control for the radius of the spheres, so let's expose that parameter on the scene. So right-click, choose Customize Parent Component, and go to the sphere SDF, take the radius, drag that into the list here, and then choose Bind New Par as master. And we can change the name of that to corner radius so it's more clear what that controls, because radius is just kind of vague if you're not looking at the inside of the network. So corner radius. And we can just clear out the help there so that's not confusing. Now for this one, let's set a default to maybe 0.2, and then the range for that we can set to maybe just 1 as the maximum there, since that's going to be really huge. And that's good enough for now. So let's close the component editor. And now we can go over to the combine, and let's add some blending between the frame and the corners there. So we're going to change the combine mode from simple union to smooth union. And now we have this blend radius that controls the amount of blending. So it would also be helpful to expose that as a scene parameter. So we're going to do the same thing as we did for the other radius. We're going to open Customize Parent Component, and we're going to drag this one in here and choose Bind New Par as master. Now for this one, on the original parameter on the combine operator, there's some logic that disables this parameter depending on which mode is selected. So notice how, since there's no number or offset for this mode, both of those parameters are disabled. When you drag parameters into the customize dialog like this, it by default copies that logic. So I'm going to go into the enable expression here, select all of that, and then just delete that. And now we can change the name for this to blend radius and update the label as well. And this is where it is useful to rename those parameters, since we now have two things named radius, but they're different. For this one, we can keep the default at 0.5. That looks good where it is. And we can actually just keep the range same too. So let's close the component editor. Now that we have the shape of a single cell in the grid, we can tile it to form the grid. So open the palette and create a modulo 3D. And we're going to insert that after the combine and connect it to the renderer. So we do that, everything disappears, and what is going on here? When you're using any of the modulo operators that tile space, if things disappear, it's usually because the original shape isn't in the area that's being tiled. So start increasing all parts of the size parameter here, and as soon as you go at all above 1, you're going to see something, but it's full of render glitches and they're really tiny. So keep going until you hit 2. So when you hit 2, we're now seeing the full frame there. So the reason that it is showing some parts when that size is below 2 is due to some kind of glitches in the render behavior that happen in like the far distance, but we'll deal with that later on. So it looks like the size parameter here needs to be twice what we have set as the grid size. So arguably that is maybe a bug, but it's just the way that modular 3D interprets a size parameter. We need to double that. So let's go to our parent component and right-click on grid size, choose copy parameter, and then go back to the modular 3D. And on the size, we're going to right-click and choose paste reference. Now we need to add that doubling, so expand that parameter, and then at the end of each one of these expressions, add ×2. You can copy and paste it if it makes it easier. So when we add that there, we're back to seeing that full size of the grid. So now if we go to the parent parameters and change the sizing of the grid there, it's always going to repeat and repeat at the right range. We can also try on the modulo 3D changing the shift parameter, and that's going to move the grid around. So that's actually how we're going to be adding motion later on, but for now, let's leave those set to 0. Now that we have a nice even grid, it's time to get weird. So specifically, we're going to be adding some bending to the grid. So open a palette, create a bend operator. We're going to insert that between the modulo 3D and the renderer. By default, it's set to bend along the x-axis towards y. What that means is that it bends up or down. The amount of bending that applies is based on how far a point is from the center on the x-axis. So let's change that to along x towards z. So again, it's using the position along the x-axis to decide how much bending, but it's bending forwards and backwards instead of up and down. So if you try changing the amount here, you're going to get things kind of expanding or contracting ahead of where the camera is looking. And there's some interesting effects there where if you increase it really high, then it starts to collapse again. So that's kind of an interesting place to play with some areas that are kind of glitches, but interesting glitches. So for now, let's set that to -0.2 so that we get some bending, but the grid is still somewhat visually coherent. Bending along a single axis is interesting, but we can get some more variation if we add a second layer. Let's copy this bend and paste it, and then we're going to insert the second one after the first and connect it up to the renderer. On this one, let's change the direction to along y towards z. So now when both of those have the same amount and it's a small negative number, you get that uniform compression of both axes into the distance in front of the camera. And then if you vary one of them to be different, say one's positive, one's negative, you can get some interesting combinations of effects there. But for now, let's keep this one at -0.1 so we can kind of still see the general grid shape without too much distortion on it. You should also expose both of these bend amounts as scene level parameters. So right-click, choose Customize Parent Component, and then we're going to go to the first bend. I'm going to drag the amount into the list, choose Bind New Part as Master. This is another case where it comes with this enable expression that we don't need, so let's clear that out. And we can change the name to bend amount 1 and do the same thing in the label with spaces, make it look nicer. And now for the other one, we can right-click this, copy, paste. So it'll create another one, automatically increment the number at the end. But that doesn't automatically set up a binding on that parameter. So we can close the card editor, go to the scene parameters, right-click the bend amount 2, choose copy parameter, and then go to the second bend operator, right-click the amount here and choose paste bind. To match the previous settings that we had, let's go with -0.1 for that second bend. Now, if you zoom in to the frame of the grid, you may notice that there's sort of this little groove down the middle of each of the bars. And that's happening because the box frame that is defining those bars is coming up right against the edge of where it's being tiled and repeated. So the solution to that is to add a little bit of padding to the size of the box frame so that it gets cut off in the middle of the shape and not right at the edge. So to do that, let's go over to the box frame STF, go into the scale parameter, and then for each of these parts, we're going to add to the expression plus 0.01. And then we can just copy that and paste it onto the other two. So now we don't have that groove anymore, and it's being cut off cleanly. And we can get back to our distortion. Now we can add even more distortion by twisting around the z-axis. Since we're only going to be rotating around one axis, we can use the axis rotate operator instead of a regular rotate. Create an axis rotate, and we're going to insert that after the second bend. Axis rotate is a simplified version of the rotate operator that only rotates around a single axis. On the axis rotate, make sure the axis is set to Z, and then we'll add a wave field to control the amount of rotation. So open the palette, create a wave field. And then we're going to connect that to the rotate input on the axis rotate. Set the axis to Z, and then increase the period to around 7. And then for the amplitude, since this is a rotation in degrees, let's use a larger value. So let's go up to maybe 20. So now we get that variable twisting along the z-axis. Let's expose that amplitude as an amount of twisting as a scene parameter. So right-click, customize parent component, drag the amplitude in here, choose bind new part as master. We can clear out the help since it's not really useful here or accurate. And let's rename this to twist amount. And then do the same thing in the label. And one of the nice things about using bindings as opposed to reference expressions is that if you rename that parent parameter, it's going to automatically update the references to it. Now for this one, we can maybe set the default to 0, so no twisting by default. And then for the range maximum, we can go up to maybe 40. So that gives us a good range from no twist to a lot. So that's a good range there. We'll go back to 20 though. Next, we'll set up the material using a standard combination of diffuse and specular shading. This is going to be pretty similar to what we've done in other recent tutorials. Let's create a modular matte. We're going to insert that between the axis rotate and the renderer. And as the complexity of the scene increases, you may notice that there's a little bit of a stall when you're connecting or disconnecting operators. That's because the GPU has to recompile the shader. So with the modular matte selected, open the editor tools menu with Alt-Shift-R. Then under Add Diffuse, we're going to choose Or and None. On the diffuse contrib, let's increase the roughness up to 1, and then we can do the same for the albedo. Then select the modular matte again, open the tools menu with Alt-Shift-R, and then under Add Specular, we can choose maybe Cook Torrents. And on this one, let's bring the roughness up a little bit to maybe 0.7, and then we can leave the front of 0.5. Now we can pick 2 different colors for the different shading elements. So let's go to the diffuse. And for this one, I'm going to go with kind of a pale orange. And then on the specular, I'm going to go with a green. Maybe like a fairly saturated green. And we aren't seeing like the full range of color there, and that's due to the positioning of the light relative to the camera, but we're going to fix that in a little bit. That's why we aren't seeing as much green in here as you might expect. Before we move on to the movement logic, let's first test out what happens when we shift the grid. So go over to the Modular 3D and try changing one of the parts of the shift here. So we'll see how that kind of moves the whole grid along. But you'll notice that in some places, the grid is going to intersect with or block the camera, so things go dark. So we're going to need to make sure that the camera is always either in the center of one of the cells or moving to the center of another cell in a single direction. So if we change any parts of the shift here to a different number, a whole number multiple of the size, so if we go to like 2, then it's effectively the same thing. But if it's a partial, so like 1, then you're going to get an intersection there. So we're going to need to make sure that our movement is taking that into account. But for now, the easiest way to avoid having the camera intersect with one of those bars is to make sure that it's centered at 0, 0, 0. And that's going to be in the middle of the cell by default. When moving in any direction, it will make it to the next cell without hitting anything, as long as it's only moving in one direction at a time. So let's go over to our renderer. And this is a good opportunity to swap out the camera. So for a scene like this that's kind of all around the camera, a fisheye camera can get a useful result. So let's select the renderer, open the editor tools with Alt-Shift-R, and under Add Camera, we can choose fisheye. And then we can delete that old lookout camera. So the default position on the fisheye camera is 0, 0, 5, and we want that to be at the center. So let's change the Z part to 0. And everything disappears, and that's happening because of this look at position. So right now it's positioned at 0, 0, 0, and it's trying to look at 0, 0, 0. So it gets confused and doesn't know which direction to face, and that causes the renderer to be dark. Now, depending on which version of the toolkit you're using, there might be an option here to just switch off the look at behavior. So if that's available, just use that. But if it isn't an option, like in this version here, for the look at position, we can just change the Z part to 1. That's going to put it kind of in front of the camera. So now, because of the positioning of the camera relative to light, we're actually getting a different amount of that kind of specular shine, so it's giving more color variation. So we'll adjust that a bit more later. Now we can try some different fisheye modes here and see which looks best. I think maybe the stereographic looks best. And it would also be useful to have this aperture setting, which is the kind of width of the lens, available as a scene parameter. So let's open the customize parent component, and we can drag this aperture in here, and then choose bind new part as master. And for this one, we can just keep the name as it is, since it's already pretty clear. Now, for camera-related parameters, I tend to like putting those up at the top near the sort of setting, or below the sort of settings like resolution. So I'm just going to move it right underneath that one. But that's just a matter of personal preference. So we can then adjust that from the scene level parameters there. Now let's keep it at maybe like 0.3. And you may notice, if you zoom in on the rendering there, that things get kind of messy and broken in the far distance. Now, there are a few different strategies that we can use to block off things that are too far from the camera. So one option would be to limit the maximum distance in the renderer settings, but that's going to cause a hard edge where it suddenly just gives up marching rays through the scene, and so it'll cut off the grid in kind of a sharp manner, which isn't going to look good. Another option would be to use a depth map from this renderer to apply some darkening or blurring after the renderer as a post-processing step. But in this case, I think the best option and the most natural look is going to be to limit the range of the light. So let's go over to our point light and switch on attenuation. Then we can increase the end up to about 10, and then we can set the start to maybe 5. So the end is going to be the distance after which everything is totally dark, and the start is the distance at which things start to fade from fully light to fully dark. So this range here of 5 and 10 gives us enough distance to see some kind of interesting effects in the distance there without getting the broken stuff that's far beyond that. You can also try moving the light around, but keep in mind that that attenuation distance is based on the position from the light. So if you move it too far from the camera, it's going to end up darkening half of the view. And if you move it really far away, then everything just goes totally dark. So let's put it at maybe like 0.3 and then maybe 1.5 and maybe like 2 on the Z. So that gives us some amount of kind of interesting coloration there and a good view without kind of cutting off half the scene. Now we can get into the motion logic. The idea is to move in steps, where each step is either up, down, left, right, or forward. We could also include backwards if we want to, but I think it looks better without that, so I'm going to leave it out. Now each step should end up in the middle of one of the cells in the grid. So there are lots of approaches for this, but I'm going to use Python to increment values in a constant chop and randomly decide which type of step to take at each turn. Now create a constant chop and we're going to change the name of that first channel to X, and we can add two more, rename them to Y and Z. And then let's rename this constant chop to position. Next, we need code that chooses direction and updates the position periodically. We'll trigger this code from an LFO, though we could also use a timer chop if you want. But it would also be nice to have a parameter, pulse parameter on the scene so that you could trigger it manually. So you could use that to step based on beats in audio or bind it to a MIDI button or something like that. Since we'll be running this code from multiple places, it makes sense to stick it in a function in a DAT that other operators can call. So let's create a text DAT, and we're going to rename it motion. Depending on your level of comfort with Python, you can either type this in as we go, or you can wait until the end when it's all written, pause the video, and then just copy it in. So on the motion here, let's go to the common page, change that content language to Python, and that gives us nice syntax highlighting. So opening up the viewer there, can scroll in, make the text a little bit larger. So let's add a function called takeStep and just put pass in there as placeholder. Maybe shrink that down a little. So we're going to be making choices based on randomization. So let's do an import random. And now we can get to writing the body of our function. So we can get rid of the pass since we're going to have real code in here. So let's create a variable called I and set it equal to random.randInt. And then the first parameter is going to be 0, and the second is going to be 4. So y0 to 4. So the directions that we're going to be choosing between are up, down, left, right, and forward. So it's 5 different options. So since this range is inclusive, this gives us values that will cover that full range. Then create another variable called p. We can set that equal to op and then put in position. So this gets us a reference to that constant chop so we can change the values in it. Then we'll check different possible values of I and adjust the position accordingly. So if I is 0, we can move to the right. So what that means is increasing that x channel, so p.var.value 0, referring to the first of the channels, plus equals 1. Then we can add another case, so elif, and missing an I there, so let's put that in. Elif I equal 1, and p.part value 0. So we're going to go left on this one. So minus equals 1, so decreasing the x. Then we can add another case, L if I equal 2. And for this one, we can do y. So p apart at value 1 plus equals 1. And then the other one for moving the opposite direction. So L if I equal 3, p dot r dot value 1 minus equals 1. And then for the last case, we can move forward on the z. And we can just use an else for that. So p dot r dot value 2 plus equals 1. And missed a p in there, so let's fix that. So this is the code for that function if you're going to copy and paste that in. Now, we want to call this function periodically. And one option for doing that is to use an LFO and a chop execute. There are lots of different ways that we can do this, but this one is good enough for now. Create an LFO chop and change the type to pulse. So now it's going to pulse every 1 second currently. And let's drop the frequency down to maybe 0.5, so it's like every 2 seconds. And note that you may not see it in the little viewer there every time it pulses just because of the way that UI is updating, but it is reliably pulsing every 2 seconds. So let's drag out of that LFO chop, hit tab, and then go to dat. We can add a chop execute, and this is going to connect it up to that LFO. So I'm just going to move things a little bit to get some room here. So in this one, we're going to be using the off to on. So let's switch on the off to on, and we can switch off value change. And that's because this channel, when it pulses, it does that little blip, it's going to first go up from 0 to 1, and then it goes down from 1 to 0. So that would mean 2 different changes, but it's only one time it's going to be going from off to on. So we use that instead of value change. So let's look at the code here. Zoom in a little bit. And we can actually get rid of all of the stuff except for that off to on function. Now we want to call into the code that we put into that motion dat. So mod.motion.take step, open parentheses, close parentheses. And that's it. Let's close that. And now every time this pulses, it's going to be taking a step in some direction. So you can see it updating that position there. So now let's apply that position to the shift of the modular 3D. So the first thing that we want to do is smooth out those changes. So let's drag out of there, out of that position chop, hit tab, and let's create a filter. So you could also use a lag, but I'm going to go with filter in this case. So on the filter, we can leave the filter width on the default, which is currently a 1 second blending. But if we're going to be changing the frequency, we need to make sure to adjust that so that it fully finishes each step before starting the next one. So next, remember how in the modular 3D, we need to go in whole increments of that size. So let's multiply out these channels by that size. So we can go parameter shop. Let's create one of those. Clear out this parameter list here, and then under our groups, you can select the grid size. Another option would be to put into the parameter name grid size X, grid size Y, grid size Z, or use a pattern expansion, but this is faster. So drag out of the filter. Let's create a math. And then connect up the parameter shop to that. And we can change the combined shops mode to multiply. And since we're matching by channel number, it doesn't matter that those channels have different names. It's just going to associate the first one to the first one and so on. And note that on the modular 3D, we are multiplying all those sizes by 2 just because of how modular 3D interprets size and other parameters. So we need to also apply that here. So on our math chop, let's go over to the multiply add page and then set this multiply to 2. And now we can add a null chop to the end, and we can rename that to shift. We can open the chop viewer, drag the first channel, the X, onto the first part of shift, and then choose chop reference, and then we're going to do the same thing for Y and Z. So now it is periodically stepping in various directions, and it's always going to kind of pause at the center of one of the cells. Next, we can add a parameter on the scene to allow manual stepping. So let's open up the Customize dialog, and we're going to change the type here to pulse, and we can add, and let's set the name to step, and then click add, move that down to the bottom, and that's enough for us to work with. So let's close the component editor. So over on the parent comp, we now have that button. So next we can add a parameter execute. So let's tabs, go over to stats, and create a parameter execute. And we can set the op path to dot dot to refer to the parent scene and add the name step. And then we can get rid of the value change since we're only going to be using that pulse. So now we can look at the code inside there, and we can get rid of everything except that on pulse. You can also keep it if you want, but I like to do this just for cleanliness. So inside here, we're going to do the same thing that we did for the chop execute. So mod.motion.take step, open parentheses, close parentheses. And that's it. And we close that. So now if we go to the scene parameters, we can hit that button and it will manually trigger a step. When we're doing that, it probably doesn't make sense to also be using an LFO, so we can add a toggle here to switch off the LFO. So let's open the Customize dialog again, go over to our LFO, and then we can drag that play parameter into the list and choose Bind New Part as Master. And we can actually just keep the name at play, or you could change it to like auto step or something like that. And it would also make sense to expose a speed setting. So let's just drag the frequency here in, and we're going to choose Bind New Part as Master. And then we can rename this to maybe like step frequency and do the same in the label. So now we can go to the scene parameters, we can switch off that automatic stepping, and now we just have a single button that will take a step kind of on demand. Probably makes sense to keep that play button next to step frequency. So let's open that Customize dialog, and then we can drag that one down below the step, or we could move the step below both of those. I'm going to switch on the auto step again. So when working on this, I decided that I think it looks a bit better when it takes steps forward more often than it does in the other direction. So the way to do that involves changing the code in that motion dat. So let's go to that, open it, expand this a little bit. So one quick way that we can do this is to just increase the range, the maximum range here, since we're doing any number greater than a 3 is going to result in that X motion, or I guess less than 0, but we're not going to include those. So we can do this as maybe 7. So now it's going to step on the Z direction, like in theory, twice as often as any of the other directions. And if we want to adjust the ratio more, we could kind of increase that. It might make sense to expose this as like a parameter, but we're not going to cover that here. So I'm going to close that. And now we can move on. So let's also add some animation to the wave that we're using to produce the twisting around the z-axis. So let's go over to that wave field, select that. Just going to move this over a little bit, right click, and open the editor tools menu with Alt-Shift-R. And then under animate with speed, we're going to choose phase. And then move this back over here. And we can drop the speed on this down. So I think it makes sense to expose that speed as a parameter, but this is just way too fast. So let's drop the first part of that speed setting down to maybe 0.5. Then we can bind that speed multiplier to a scene parameter, and that 0 to 1 range will get mapped down to a 0.5, which is more reasonable. So let's open the Customize dialog, and then drag the speed multiplier in, choose Bind New Pars Master, and then we can rename this to Twist Speed, and do the same thing for the label there, Twist Speed. And maybe, yeah, we can leave that range maybe 0 to 1, and we can have it default at that 1 value. And that's it for our scene. So to recap, we're starting with a box frame. That's going to provide the bars in the grid. Then we are combining that with a sphere that's been mirrored across all 3 axes, spread apart using the offset. And we're using parameter expressions to make sure that that always matches that spacing of the grid. And then we're blending that with smooth union. Then we are using modular 3D to tile it to form a grid. And then we apply 2 different levels of bending. And we're doing it along, X towards Z, and then also on Y towards Z. And we have separate controls for each of those. Then we're applying some twisting there using an axis rotate and a wave field. It's all on the Z-axis. Then we're using a modular material with a diffuse shading element and a specular element. And finally, we render it out and send it to an out top so that people using the component can access the result. So if we go up here, we now have a nice component here with lots of parameters on it that produces that stream of rendered video. There are lots of ways that you could extend this scene. So one option would be to insert a modulo polar, maybe after the twist here. And that's going to give you sort of like a kaleidoscope effect. It kind of loses some of the grid structure and the sense of motion, but it does produce some pretty interesting results. Another option would be to try different types of distortion instead of the bend, like maybe a 4D rotation. And that could produce something interesting too. Or you could try a different type of blending between the corners and those spheres at the sides, or you could use a different shape other than a sphere. Maybe something like a stair blending would give you a kind of stepped pattern along each of those corners. I look forward to seeing what you all do with the scene. If you post on social media, use the RayTK hashtag. And at least on Instagram, tag me to make sure that I see it if there's stuff that you want to show off. If you want to support RayTK development, check out my Patreon. You'll get early access to tutorials, exclusive scene downloads, and more. Thanks for watching, and as always, make sure to like and subscribe.